Welcome to second semester of pre-calculus, where luckily for you, we're going to be dealing with trigonometry basically this whole semester. Okay, so in chapter 4, the basics of trigonometry, we talked about this in Algebra 2, but just like everything else we've done so far this year, we're going to go more in depth with it. So in lesson 4.1, we're going to be talking about angles and their measures. When you talk about angles, in the past we've always dealt with degrees. Okay, there's 360 degrees in a circle. All three angles of a triangle add up to 180 degrees. Okay, that's what we started out learning first. In this lesson, you're going to learn that there's two different ways we can talk about angles. One label is degrees, the other is radians. Okay, if you watched the video that I posted on the website, that lady from MIT talked about degrees versus radians and how we convert between those. If you have not watched that video, I recommend you do that. Great. I'm just going to go through the basics of this lesson. If you watch the other video as well, that's really going to help you understand this. So the first thing we're going to talk about is converting between degrees and radians. To convert radians to degrees, we simply take that value and multiply it by 180 degrees over pi. Okay. If you watch that other video, she would have labeled this as pi radians. The label for radians is RAD. We don't necessarily have to write that RAD in there. Okay. If there's no degree symbol written in there, if there's some form of pi, that's showing us that that label is radians. Okay, it's understood to be that label. So we don't necessarily have to write it in there. The second conversion, to convert from degrees to radians, we multiply by the reciprocal of the last one. We're going to multiply by pi over 180 degrees. So now we're going to use those expressions for the conversions between the two to convert from one form to the other. Okay, so in the first one, if we look, we have 60 degrees. So if we're in degrees, we want to convert that to radians. So the conversion, if you look back, to go from degrees to radians is we multiply this by pi over 180 degrees. Okay. If you think about 60 degrees, that's the same as 60 degrees divided by 1. To remember which conversion you have to use, if 60 degrees is in the numerator and the other, or in the original, it must be in the denominator of the other one. Okay? If we have degrees in the numerator and degrees in the denominator, well, anything divided by itself cancels out, so that degree label cancels itself out. Okay? So we have 60 pi over 180. Okay? So degree in the numerator, degree in the denominator, those cancel each other out. So now if we look at 60 divided by 180, okay, those have a factor of 60 in common. So that simplifies down to pi over 3. So we converted, started with 60 degrees, used that conversion expression, changed it into radians. Okay, just like I talked about previously, we could technically label this as pi over 3 radians. If it's not written in there, it's understood to be that. Okay. The second part, we have pi over 2. Okay. Now we're going to use the other conversion expression. We're going to multiply this by 180 degrees over pi. And just like the last expression, we talked about determining which one we have to use. If we have a label of pi that we're starting out with, then we know we're going to have to use this conversion. That way our pi units will cancel out in the end. So this is equal to, our pi's are going to cancel each other out, 180 degrees divided by 2, which we know 180 divided by 2 is 90 degrees. Okay. So pi over 2 radians is equal or equivalent to 90 degrees. 60 degrees is equal to or equivalent to pi over 3 radians. So converting from one form to the other. The next thing we're going to talk about is the arc length formula. Okay. We're talking about a circle. Okay. And we have some central angle drawn in here. The arc length is referring to this distance around the outside of the circle. Okay, so that's the arc length. This central angle that we're talking about here is labeled with something that looks like a circle with a little loop through it. This is called theta. Okay, one of many Greek symbols we talk about in math, that's theta. It's referring to the central angle. So we have two different formulas we're going to be talking with when referring to arc length. First one is in radians, which is pretty simple. S equals R times theta. Okay. This is going to be the one we use most often. When we're talking about trigonometry, we're going to be using radians basically probably 95% of the time. Radians are a lot easier to work with actually rather than degrees. So we're going to be using this formula more often. The other formula in degrees, which we still will use at times, S equals pi times R times theta divided by 180 degrees. So if you look at this part of the formula, pi divided by 180 degrees, that should make sense. We're using a degree to radian conversion, so that is where that part of the formula comes from. Okay? So we have a few variables. We got to make sure we understand what they stand for. S stands for the arc length, theta is the central angle, and R is the radius. Okay. So converting or finding the arc length when given a central angle. So we're going to go through an example of finding the arc length. Okay, this is basically a portion of a circle. Okay, you can think of a slice of pizza or a slice of pie. Okay, what the shape is looking like. We know the radius is 18. The central angle is pi over 3. So if that central angle is pi over 3, it involves pi. It doesn't have a degree symbol. We know we're working with radians. So if we're working with radians and we want to find the arc length, we're using the formula S equals R times theta. S is what we're looking for, the distance on the outside. Okay, that would be like the crust of the pizza. S is equal to, our radius is 18, times our theta, the central angle, is pi over 3. So now if we want to simplify this, 18 divided by 3, 6 and 1. So our arc length is 6 pi. So that would be the length, the distance around that portion of the circle. The last example we're going to go through, okay, since I know how much everybody loves Mile Wednesday, we're going to talk about a problem dealing with the track. Okay, so we're going to find out how much longer it is to run in lane 2 compared to lane 1. Okay, so what we're looking at here is just a portion of one end of the track. Basically, this is forming a semicircle on one end. The distance from the center of the track to the inside of the first lane is 33 meters. The distance from the center of the track to the inside of the second lane is 34 meters. So using this information, we got to find out how much longer it is to run in lane 2 compared to lane 1. So basically, we're going to be looking for the arc length. If we're looking for the arc length, there's two things we need. One is our radius, which we have. The second is our central angle. So if we're talking about a semicircle, we know there's 360 degrees in the circle. So half of 360 degrees is 180 degrees. But we're going to use radians because radians are easier to work with. Especially for those of you who take calculus, we're not going to deal with degrees at all. We're going to be using radians, so we're going to use radians now. 180 degrees is equivalent to pi radians. So our central angle is pi. A semicircle is pi radians. Since we're dealing with radians, the formula we're going to use is S equals R times theta. Our arc length is equal to the radius times theta. So if we're looking for, let's say, S of 2, we're looking for the arc length of lane 2. So we're basically trying to find what that distance is. That is equal to the radius, which is 34, times the central angle, which we know since it's a semicircle must be pi. Then we're going to find S1, which is basically the distance of that inside part of lane 1. And that's equal to our radius is 33 times the central angle, which is pi. So we know what those two distances are. We're trying to find out how much longer lane 2 is than lane 1. So we need to subtract those values. So 34 pi minus 33 pi is equal to just pi, which is approximately 3.14 meters. So if you started at the same point and you ran around to the equal part on the other side, so you ran that semicircle around the turn, the person in lane 2 would run 3.14 meters further. Okay? That's why in track, when you're running 200 meter dashes or 400 meter dashes, that's why the people in the outside lanes have to start further ahead. Okay? Because of that change in distance the further you go outside on the turns. Okay. So that concludes lesson 4.1, talking about degrees and radians, converting between them, finding arc lengths. If you have not watched those 3 videos I posted on the website, I highly recommend you watch those. Those are going to help you a lot. And then when you're done with that, you can go ahead and start watching the 4.2 video.